Ricardo? Okay, let's get going. Good afternoon. I'm Ramasubramanian, Vice President for Research. It is my pleasure to welcome all of you to this public event to discuss precision health for populations and generate actionable ideas for moving the needle on this topic from prominence to preeminence at UVA. I want to thank you in advance for your participation. The university's Great and Good 2030 plan identified 5 focus areas, namely democracy, environmental resilience, sustainability, brain and neuroscience, digital technology in society, and precision medicine/health. These areas were identified originally on the basis of strengths existing at UVA and where we can move the needle to preeminence in the first place. It is the vision of the Grand Challenges program to invest significant resources in these areas, identify key foundational questions that will be addressed effectively under each of these areas, and move the research profile from prominence to preeminence in all of these areas. Last year, as you all know, we provided $60 million towards advancing the environmental resilience sustainability area to put climate change solutions in people's hands. And nearly $75 million for brain and neuroscience research to make significant advances towards understanding Alzheimer's disease, autism, and developmental neuroscience. We are focused on building research capacity in our strategic areas, and this year we are focused on building UVA's research capacity in digital technology and society and precision medicine and health. We have charged faculty steering committees to help determine how best to focus our efforts. They are consulting with deans and faculty across grounds to identify areas of research where UVA could move the needle and have strength in solving urgent societal problems. The primary purpose of these investments is not to directly support research 100%, but to drive towards a solution and help build a research team that can be competitive when we actually apply for grants from funding agencies, foundations, also support graduate students, postdocs, to really strengthen our infrastructure so we become highly competitive. The topic for this session is precision health for populations. It's a capacious topic that will involve several disciplines, as we all see around the room, to frame meaningful problems and build an interdisciplinary team around the topic. Simply defined, again, this is my version of it. You are the experts. Precision medicine is customization of treatments at an individual level using relevant elements of individual's genome, for example. Precision health for populations is a highly interdisciplinary area of study to account for the role of all factors, including genetics, the environmental, socioeconomic factors that affect small targeted population, on how they will respond to treatments and interventions that are usually broader than therapeutics alone. Rapid advancements and breakthroughs are being made in precision medicine. I'm sure all of you are following the news, this community for sure. On Wednesday, we had a personalized vaccine for melanoma announced. This is Moderna announcement, which is an mRNA-based vaccine that the vaccine adapts to the mutation patterns that is specific to a patient's tumor. This is revolutionary, and more things of this nature to come. While precision medicine will be advancing at this great clip, there is significant additional revolution taking place that will give us additional tools to advance precision medicine and health. Advancements in big data science, rapid rate of accumulation of patient data, with cyber-physical systems that feeding all this data, significant maturation of AI technologies, as well as rapid scalability of custom computer hardware as GPUs that enable precision medicine to truly make these advances into precision health for populations, where these types of precision medicine outcomes can be readily developed for specific populations that are not only subject to genetic factors, but also other factors that are determinants of health. The impact is likely to be manifold. You are the experts at this. We have gathered here to discuss each other's strengths, brainstorm current state of techniques and technologies across disciplines to develop a vision for compelling problems in precision health and for populations, and strategize how we can move from the state of prominence to preeminence. I look forward to hearing your discussions and learning from you the direction we should take, and how we can move the needle on this topic. So this day is quite exciting, and thank you very much for assembling here, and I'm looking forward to listening to your discussions. And now over to Karen Ingersoll.
Good afternoon, everybody. Thank you so much for coming. This is a fantastic turnout. We're very grateful for your interest and participation today. I want to sort of give the frame of what we've been working on for 6 weeks or so in the steering committee. UVA, we hope, will become the preeminent university in precision health for populations by the things that Ram was just talking about: investing in expertise and infrastructure, developing new tools and technologies, and involving community and university partners in a significant way statewide using ethical, social justice, and democratic principles. Now, I want to express gratitude to the leadership that have initiated this process. President Ryan, Provost Baucom, Ram, you just heard from, and Megan Barnett, the Vice Provost. Also, I want to call out our logistics team, Shelley Lovelace, Cindy Orange, Dolores Roberts, for terrific support to arrange this event in a very fast way. And of course, the steering committee, you see their names here, who have worked, like I said, for the last 6 weeks. We have a sprint to the finish. By March 31st, we're going to be turning in a white paper that will synthesize what we hear from speakers today, as well as from your participation afterwards, to actually answer some discussion questions that will really guide us going further. So your work really counts here today. So our plan is we'll do a series of expert presentations. They're going to be kind of long elevator speeches, if you will, so hitting some high points very quickly. We'll then move into breakout groups with facilitators. And at the end of that time, we will hear reports back from each group on what should be the foci of this initiative, what would make it unique and capitalize on UVA strengths, and what resources do we really need for preeminence. And to thank you all for all this work you're going to do, we'll host a reception outside the doors when it comes to that time. So once again, thank you for being here today.
Good afternoon. Can you hear me okay? All right. So it's my pleasure to be here to start the presentations. Hopefully, I'll give you some framework for why I think having a health equity focus as we think about precision health and precision health in terms of populations is important. And hopefully this will give you something to think about as we hear subsequent speakers. So often when we think about disease and disease outcomes, we think about health disparities, which is the disproportionate burden and differences in disease or death, usually by some group, usually race, ethnicity, gender, socioeconomic status, et cetera. But now we're in a phase where we can start thinking about health in terms of health equity. And this refers to the concept that every person has the opportunity to attain his or her full health potential, and no one is disadvantaged from achieving this potential because of the socially determined circumstances. When we refer to those socially determined circumstances, we often hear the term social determinants of health. And this encompasses a number of things, including access and quality of education, healthcare, economic stability, your neighborhood, built and physical environment, as well as lived experiences, which encompasses both social and community context. So visually, when an individual presents to the ER or their PCP, we usually see that physical disease, or we hear the reports of the disproportionate burden of certain health disparities. But to fully embrace the concept of health equity, we have to think about all of those underlying factors, right? Those unseen contributors to health and health outcome. Some of that is biology. For many of us in the room, that could be one's genetics. Some of that could be lived experience or environment, stress, racism, for example, and also quality and access to healthy foods or quality of care or education. So those are all things that we need to keep in mind as we think about the full picture of one's health and healthy outcomes. Traditionally, we think about precision medicine in the terms of pharmacogenomics, right? Where you have this large group of individuals, a large patient group with the same diagnosis, same prescription, but we know they don't all have the same outcomes, right? So we can think about ways in which we can avoid individuals in which a drug is toxic and not beneficial. That would be the individuals, let's see if you can see here, with the X's. And then we have this ideal group where the drug is not toxic and is also beneficial. Those will benefit regardless. But pharmacogenomics also offers us an opportunity to think about how to save those individuals here colored in green in which the drug is toxic but beneficial. So they might benefit from dosing strategies and things like that. So traditionally we think of pharmacogenomics as that elimination of the one-size-fits-all approach, but precision medicine in general with the goal of giving the right treatments at the right time, every time, to the right person. And if we want to take that to the next level, thinking about populations, precision public health really focuses on delivering the right interventions to the right populations, right? So this utilizes data and technology, oftentimes genomics, big data analytics, in public health practice to target communities or small groups with precise health interventions. So when we think about the big picture of public health, precision medicine, we need to think about the biological determinants, the social and behavioral determinants, one's environment, whether it's physical, lived, exposures. Rural is a big one I think we should think about. And then hopefully how we can integrate clinical data into that picture. So electronic health records, biomarkers, etc. In order to be successful at this approach, we really have to embrace expertise in genomics or multiomics, public health, and hopefully even biomedical informatics. If we do this successfully, this could lead to improvements in policies and practices that can truly benefit the healthcare system as a whole. So I think we also need to be mindful that diversity is going to be essential for a successful precision medicine or precision health initiative. We know that individuals tend to do better when from a clinical perspective, minority patients have better outcomes when they receive their care from from practitioners that are of the same race or ethnicity. So representation matters. Having people who look and sound like the communities they serve is important. With that representation, hopefully that can lead to increased participation in biomedical research and clinical trials. That increased participation or diversity in participation will ultimately result in broader translation in which we can generate data and results that are relevant or applicable to a diverse population. And then if we're successful with that, that can lead to the ultimate elimination, curing diseases, eliminating disparities and other barriers. This is extremely important. Our country is in the middle of a change of demographics. So this figure here just shows that the projections for 2050, so by the year 2050, people of color are projected to make up over half of the US population. So if we do not include diverse clinical trial participants, biomedical research participants, in 20 years or so, we will have half of the population that probably will not be able to benefit from those findings in the lab or those genetic studies, et cetera. So I promised that I would be less than 7 minutes. So in summary, I think we're in a great position as a university to be leaders in precision health, especially with the health equity lens, right? We're a large university with regional influence, a strong public health, omics, funded comprehensive cancer center, a robust and successful healthcare system. So I think that's also very important. With that, hopefully we can be a national leader in rural health. I think that's an important opportunity for us. And then we'll also be well positioned for education and training pipelines that embrace diversity, equity, and inclusion. With that said, 7 minutes on the dot. Questions?
hold on.
What you said about what has to come together. That's my Italian in me. My arms are flying everywhere. So I really agree with you bringing in all these different groups. That's really very, very valuable. But I would argue there's another level of bringing in sensors and collection of data and dealing with the lower level engineering coming in addition to everything you said.
Absolutely.
Yeah.
Absolutely. More data, more power to
But
to
it's
address.
also deliverable, delivering the health care to individuals on a 24/7 basis, for example.
Yep.
Yes, yes.
Is that my one?
Hi, Dina Hallman, Cancer Center. So I appreciate your mentioning rural as an area we might excel in, and I'm wondering what your thoughts are about how we balance that with other specific groups within our catchment area, so to speak. So the Cancer Center thinks about catchment area a lot, and as the health system now moves north with all of these acquisitions, I wouldn't call it, I'm from Brooklyn, I wouldn't call it urban, right? But it's not rural either, and so it's also diverse in different ways. And so just wondering how, if we position ourselves to really excel at something, what should that something be, and how do we balance rural versus other areas?
Yeah, well, I think the ultimate goal is to make sure we improve health for everyone, right? But if you think about the unique population immediately surrounding Charlottesville, that's why the first emphasis on rural. Also, if you think about where the major disparities exist, usually it's poor, minorities, et cetera. So if I had to rank, I would probably start with rural and minorities. But you're right, I think as the catchment area expands, we want to figure out what those individual populations or subpopulations, what their needs are as well. So we don't want to exclude anyone, but we want to figure out ways that we can be most competitive. I think we have an advantage here in the state where to the east and to the west, there's a lot of rural places, so there are opportunities to partner with EVMS, for example, where we can get those outer extremes of the state as well. So. And again, I'm fairly new here, so I don't have all the answers. So I'll just this is my 2 months worth of observations and where I think we can head as a organization, as a university. So.
Thank you. Thanks for the opportunity to talk today. I'll start with a question for the crowd. What percentage of individuals in their entire lifespan do you suppose will experience a diagnosable psychiatric disorder? If I asked for a show of hands over 50%, how many would agree? Okay, most. What about over 70%? Some. It's actually about 80%. Newer studies in kids have shown by kids, and this is a sample over in the UK, they've shown by kids, by the time they've reached the age of 14, near 40 or 50% of them has some kind of precursors to mental and psychiatric disturbances. So this is something that occurs quite early, has a long sort of legacy, and creates many health problems going forward. One of the questions that I've been fascinated with is, what about the other end? What makes good health? What allows people to be basically buffered against this? And it's not the usual factors, such as socioeconomic advantage, non-exposure to dangerous toxins, et cetera. There's a lot of very small influences that make a big difference. So I, along with others, study a lot of brain science. And one thing that I like to point out here, because this is a simple way of thinking about mental health, is one of the most prevalent models is connections between the prefrontal cortex and the limbic system. And this little circuit, which starts to emerge in childhood, follows a pretty interesting developmental time course. When kids are very young, anyone with a young kid would know when they get upset, they often throw tantrums, throw themselves on the ground, need to be calmed down by a caregiver. They don't have very good self-regulatory processes yet. In their brain, they have this connection between these two areas, which is positive. So both areas get really ramped up, the child gets ramped up. Over time, what happens is the prefrontal cortex and the limbic system start to become negatively correlated in that it seems to be an inhibitory circuit. So as you get ramped up, the frontal lobes start to become more mature and they help you settle down in some ways. And you can see that this changes from early in life, this positive relationship, to later in life, this negative relationship. And it looks like I'm missing my points here, but this is that this negative relationship matters for things like self-control. For instance, this is from data from our own lab, where we found that kids that are higher in parental reported self-control have a stronger negative relationship in this area. They've actually looked at this in lots of different populations. You can see in typical development this normal relationship where there's this positive relationship between these two areas in children, and then in adolescence it starts to become negative. This is just in typical development. If you also look at kids that have had more of a harsh development, they've studied children that grew up in Romanian orphanages, kids that were institutionalized very early, did not have a lot of contact, had a lot of neglect in their life. They actually show an accelerated development of this circuit to where they begin to show more of an adult-like profile early on in life. And this is thought to be very protective. The brain is wiring itself to account for the fear and uncertainty in their environment. In our own work, we see similar trends, but they become more complex. One of the things that we found is by looking at an epigenetic modification on the oxytocin system, which is really important for child rearing, really important for relationship bonding. The children that are higher in oxytocin receptor methylation, which is often an occurrence that we see in kids that come from lower care households, less interaction with parents, less positive interaction with parents, they actually, and a subset of them show greater maturity of this circuit, which I'm just highlighting down here. And this is buffering them from internalizing behaviors. So they're showing this buffering of these internalizing behaviors. But the thought is that later on, they're going to go on to experience more risk for psychiatric disorder. So early on, this buffering is good, but it's not developing the brain in an optimal fashion to protect against psychiatric disorders later in the lifespan. Now, in the laboratory, this is work from my collaborator, Jessica Connolly, you can see the impact of this early life experience. And you can do this in a model system like a prairie vole in this case, where they take high and low care environments, so they can easily manipulate this in the lab. And what they find is that the voles that have more high care parents have less decelerated aging. So they have this measure of epigenetic aging, which is a composite measure, which is a measure of biological aging. The voles with low care parents age quicker. They are less healthy as they get to be adult age. They are more susceptible to dying a little bit earlier. Voles don't live that long, so we can model that out fairly fast, and we can understand this direct impact. This is also true, though, in humans. So work from Joe Allen, who's in our department, and Jess Connolly, they looked at early life experience in the form of how adolescents and their relationships with their parents and their peers during junior high then influenced what their epigenetic age was a whole 15, 20 years later. And sure enough, the adolescents that had good experiences, good relationships with parents and with peers, they were they were lower in epigenetic age than those that had the worse social relationships in this way. So this leads us to a lot of questions. So what is a good environment? All these things are interacting. Genomics, epigenetics, environment, exposure, brain development, maturation. There's protective processes. There are compensatory processes. And then there's common sense measures, and then there's non-common sense measures. So when we get to the point of saying, well, what's good for a teenager? We might say, well, good is the opposite of bad. This is bad, right? So this phone is bad, so we take the phone away. Well, that actually doesn't improve problems. They found that people taking phones away creates periods of isolation in kids, and it's not actually the most optimal response for every child. On the other hand, people would argue, too much of this is bad. So what is right? So we have to know what is good. What is good parenting? What is a good daycare environment? How do we account for multiple interacting influences? Again, I pointed it out. You can go from the biological to genetic to the environment to circumstantial issues in terms of the way that people have dealt with various exposures. And then finally, how do we intervene? In this case, intervention would be really thinking strongly about environments and thinking strongly about guidelines. And then finally, I'll point out some ways that we can really start thinking about this in terms of investment. Longitudinal sampling across the lifespan. So any point in time, any measurement we make is bound to be limited in its capacity to tell us much about the trajectories of how these multiple levels of analysis are interacting with one another. We need better and more informed sampling across the lifespan, starting as early as prenatal sampling. Broad sampling of genetic, biological, behavioral, and observational data. We're good at collecting all these things. We have amazing ways of analyzing these things. We have ways of thinking about the bioinformatics, about thinking about the way that these things change under certain conditions. And then finally, improved data science and bioinformatic approaches to understanding these trajectories of development. In my own department, we've always been heavily invested in understanding longitudinal samples and understanding change over time. Obviously, with the expansion of data sciences at UVA, it's another area where we have a lot of effort in already. So this is just sort of the way that I see things, is that precision health and precision medicine really needs development and really needs to start early. Early life leads to events all the way until end of life in terms of our health. Thanks.
Sorry. What kind of ways do you think we can measure these, collect these large longitudinal data sets?
Well, in some ways, we've already started. One of the problems that we have is everyone collects their own set, right? So we collect data. I have collaborators that collect data in the NICU. We follow those kids later. We test them years afterwards. We have our own longitudinal set. We have at least 3 or 4 different longitudinal collections in psychology. One great idea would be to really get an epidemiological approach and build a very large sample that would have a number of researchers engaged from across the university. And in this way, you would have the appropriate materials banked, biological materials. You would have the appropriate thought put into sampling and how that's representative of the area of Charlottesville or of the country and as a whole.
So you're thinking like Framingham heart study?
Yeah, things like that. But I mean, it doesn't have to be in a similar scale. You can gain a lot from being more thoughtful, from sampling from the beginning, and from having multiple investigators capitalizing on that in terms of grants going forward and things like that. Yeah.
Next we have Provost Baucom.
So this is my talk. It's only like 45 minutes. No, actually, I'm going to be incredibly brief. I just wanted to join you to say thank you. I'm sorry I couldn't be here earlier on, and I will need to step out. But this is a consequential gathering. I know you're going to hear a lot of presentations, but I think this is one of those days where it is worth spending that time with each other. We are going to move from here to make significant investments, and significant investments in the research future of the university. And one of the things that I have learned in the short time that I've been provost, in addition to the fact that apparently being provost is an epigenetic factor that contributes to accelerated aging, which I experience every day, particularly sometimes when I wake up and read the Washington Post. One of the things that I've learned from many of you over the course of this past year is how important it's been for us within the enterprise of pursuing our grand challenge research initiatives to be thinking simultaneously about precision medicine and precision health. And I just really want to pause to thank you for that. It was not originally fully on our horizon that we needed to do both. And we have benefited from all of you in the thought that you've given to us in making that determination. We will move from here. we will move not by the end of the day, but we will move by the end of the semester to make significant investments. Investments on which we need your recommendations, on which we need your creativity, investments in faculty hiring, investments in core equipment, investments in common projects. And I think that, know, believe, and hope that you will find that the hours that you've spent here today are actually going to leave a legacy in the life of the university for a decade or more. So just deep thanks to you for that. Karen, thank you for chairing this steering committee. Thank you to all the members of the committee, but thank you to you in particular for all the work that you've been putting into this. I'm really, really grateful. And also to my colleagues, Ram and Megan, who've been guiding and steering this process. I'm thinking about it every day. It's great to work with you. So thank you, friends. Thank you, colleagues. It's good to be here. I'm going to stick around for as many of I believe there are 17 presentations, as I possibly can. So, but it's good to be here, and we're looking forward to seeing what you recommend and investing in the work that you do. So thanks so much.
Hello everyone, and greetings from India. I'm so sorry I can't be at today's fantastic events in person, but it is fitting in some ways that I'm making these remarks from the largest democracy in the world. The questions of democracy, of community and solidarity are some of the most difficult in thinking about how to get precision medicine off the ground. The tension lies in the very title of today's event, Precision Medicine for Populations. Precision medicine implicates, even glorifies, individuality. It imagines medicine tailored to the individual, to their specific genetic profile. And recent work has also argued that social determinants of health should be integrated into our understanding of precision medicine. After all, an individual's medical profile is a product of the interaction of both biopsychological and social factors. But the focus is very much on the individual. But precision medicine for the individual cannot be done without populations. Precision medicine imagines vast troves of data regarding various aspects of individuals' lives, genetic and biometric data to be sure, but also their diets, sleep patterns, income, housing, take your pick. And asking entire populations to contribute data in that way is asking a lot. So can we, as a democracy, forge ahead asking so many to sacrifice for potential benefits that may or may not come about? I believe the answer is yes. And given that I am closing out this panel, I'll try and be brief. At the outset, we ask individuals to sacrifice resources for the greater good all the time. Individuals have to pay taxes. They cannot always build their buildings as high as they would like. They cannot play music loudly after a certain hour. The government may also come in and take your property for an appropriate price, of course. And there's a lot of writing about how we can justify these burdens, but at least two common threads emerge. One, from a rather Hobbesian perspective, says that we get benefits from living in a civilized society. In the context of precision medicine, we will likely benefit from a system of precision medicine ourselves. As the late Justice Ginsburg observed in the first Supreme Court challenge to the Affordable Care Act, quote, every US domiciliary will incur some significant medical expenses during his or her lifetime. Now, even if she exaggerates, the vast majority of us do benefit from medical care and will benefit from a robust precision medicine system. And even for those of us who will never see a doctor in their lifetime, benefit when their loved ones, employees, friends, colleagues, the people who make our lives rich, meaningful, and productive, have access to great medical care. The second reason we can make this ask of individuals is because it is a good thing to help those who are vulnerable, people with ill health who will need precision medicine the most. Now, economists think in terms of marginal analysis and moral philosophers in terms of deontological claims, but at some level, for a democracy to truly function, we need everyone to be able to participate in all aspects of democratic life, in public debate, in voting, in public service. And that will not be possible if we do not take care of those of us who are least fortunate. The arguments have advanced so far talk about distribution of resources and say very little that is distinctive about precision medicine. Indeed, as my shout out to the notorious RBG hints, many of these arguments reared their head in the ACA context when many asked why they should pay health insurance. But notice that each of my arguments ended by thinking about community, about participation, about democracy. And I think precision medicine has something distinctive to say about that. Precision medicine represents a shared effort by a community, an expression of common purpose. And I use the word represents advisedly. The data that the project collects is a representation of ourselves. It tells a story of who we are, our bodies, our minds, our lives. The only way precision medicine can work is if each of us contributes something that is personal, not money or even labor, which as academics we know can be quite personal, but something that is even closer to us, that constitutes us. Each individual profile represents the paradox of precision medicine. It is unique and individual, but at the same time, its value can only be realized by situating the individual in the community. Precision medicine is thus a space of collective action, where each individual contributes equally of something that is personal to themselves. It is arguably an exercise, a demonstration of democracy, which is itself a collective imaginary. But precision medicine is not just a representation of who we are. It is an expression of vulnerability. After all, the purpose of the project is to understand and situate these vulnerabilities at both an individual and collective level. If deployed correctly, precision medicine thus could be a space where each of us can, through this common project, empathize with each other's burdens and weaknesses, similar and different from our own, which together represent our common humanity. I look forward to working on this project with you. Thank you for having me remotely.
Hi, I'm Laura Barnes, and this is Lee Ritterband. I'm in the School of Engineering, and today we're going to talk about digital behavioral health, which I think dovetails nicely with everything that's already been discussed. And so what is digital behavioral health? I think we all know that, we heard from Jamie already, that 80% of people in their lifetime, this says 50%, so we already see a statistical difference, but will have a behavioral health crisis in their lifetime. And existing healthcare models, and this is even before COVID, that emphasize one-on-one in-person care, are not effectively closing the treatment gap. So we need models that look at more innovation and accessible ways to get services to people when they need them. And so what is digital behavioral health? And so we define digital behavioral health as any application of digital health technology that is for behavioral and mental health support, prevention, and treatment. But the key difference is we're thinking about how can we use behavioral health to personalize and tailor to the individual, thinking about rich longitudinal data streams at the individual level that can be used to deliver in-person care. And so why is UVA the right place for this? So thinking about digital health across grounds, this touches 11 different schools, from the School of Medicine, focusing on digital health interventions in the Cancer Center and across different areas, the School of Nursing, thinking more through policy in the School of Law, Batten School, the School of Business, how do we translate these digital health interventions on a larger scale? And then the School of Engineering, thinking about how we design innovative technologies, next generation sensors, wearables, these pervasive elements that are in society. How do we innovate in this space and make healthcare more accessible? And so we're uniquely situated in that we are all in a tight-knit grounds. It's like it's a mile across to the hospital from engineering and all these various places. So we are set up very strongly to be able to innovate in this area. And why UVA more so? We have a portfolio of digital behavioral health interventions tailored to diverse populations and sustained funding already at an individual level. So we have a lot of successful individuals, but we don't have a really tight connection. And this is what this digital behavioral health initiative would bring us. So we have this deep domain expertise coupled with the next generation technology in the School of Engineering and the Link Lab, software and algorithms for behavioral health that uniquely positions us for success. For example, we've been working on digital health and tailored versions of interventions for anxiety with embedded sensing, enabling technology across the Link Lab to be able to better sense human behavior and how it influences health, positive links for HIV care. And then the Center for Behavioral Health Technology, Lee Ritterband's group, works on shut-eye for sleep and a lot of different interventions tailored to individual level and diverse populations. And now I'll pass it over to Lee.
Thanks, Laura. Yeah, as Laura is saying, we are doing a lot of great work across grounds, right? There's a lot of significant work being done, but most is really siloed. And by bringing together these different groups, we really could have an opportunity to have a sum that's much greater than the individual parts, and would allow us to really do some great and maybe good things. This is an idea that we've actually been thinking about for some time. Laura, Jack, Bethany Teachman, who's not able to be here today, in thinking about how do we bring these things together. And we started to come up with these hubs, these ideas of areas of focus that would really allow us to create a foundation for this kind of digital behavioral health work that's being done here. These hubs across grounds focus on many of the things we've already talked about today, but certainly more that we're going to be hearing about over the next several talks as well. Policy, privacy, equity, the creation of digital applications, etc. So a lot of work that's being done, a lot of it being siloed, with a real opportunity for creating something big. So with this idea of having some kind of umbrella group, this alliance of some sort with people doing digital behavioral health, I would imagine many of you here would put yourself in that category, or at least feel like some of the work that you're doing is connected to that. We could have these two streams that are going together. One is really this development of additional behavioral health applications, programs, interventions, treatments that we can be building out over time and testing and empirically validating. Another is the creation of this novel technology, developing and evaluating these kinds of engineering-based and technology-based applications, and bringing these together to actually be able to do things that we couldn't do separately. We then have this opportunity to begin to truly do something that nobody is doing yet today, which is to begin to implement these in a real way. And one place that we could implement them is the Cancer Center. Hopefully Tom and Dina Tom will be able to share a little bit more with some of his thoughts, but this idea that the Cancer Center is perfectly primed for this kind of implementation. There's already a model in place, the Cancer Control Continuum, which perfectly aligns with this kind of work. Each one of these areas within the continuum needs these kinds of applications, allows us to broaden access and improve availability of different types of prevention, diagnosis, treatment, and certainly well into survivorship within cancer patients. So we could use the Cancer Center as a real use case. Can we do this true implementation? Can we integrate it into our systems? Can we connect it into our EHRs? And can we then make it available to our patients and community? And as we begin to do that, or as we begin to build that out, we then have a real opportunity to expand that across other domains, whether it's in diabetes or in cardiovascular disease, HIV, any other area where we'd be able to expand that, truly putting UVA as a model for this kind of approach, something that we have a real opportunity to do that hasn't yet been done. I'll stop there. Thank you.
Time for 2 questions.
Kara?
Thanks. I have a question. So your health hub, or behavioral health, digital health hub, sorry. Thanks. I really like that idea. Your example is pretty clinically focused, so I wonder how you guys envision the hub also interacting with communities or being kind of outside of clinical care as an important additional population.
Yeah.
I think it does tell great, because we're thinking about how we can make health-related interventions more accessible. So having this model in these hubs will allow us to actually deploy to larger communities and have the infrastructure to be able to have larger scale. I think one of the comments Jamie made resonated with me. It's really hard to track people longitudinally. We need like sustainable models and sustainable technology to be able to deploy interventions and be able to actually have that longitudinal data. So it's hard to do. So thinking more like what they're doing with the Framingham Heart Study, and like, can we track people longer term and get communities involved in this? So the same sorts of technology, I think, map and methods map very well to that.
Anything else? Other questions? All right. Well, thank you very much.
Thank you.
Thank you. Fortunately, I won't talk about genomics or multiomics, but I thought what I'd do is tell you a story that started about 5 years ago. And this is actually coming out of a presentation that the president of the American Diabetes Association and the European Association for Study of Diabetes made at a conference, and they found out their presentations were almost identical. And at the end, the conclusions were we need precision medicine for people with diabetes. And so what happened then was Will Cephalou, who was the Chief Scientific and Medical Officer for the ADA, decided to set up a precision medicine and diabetes initiative. And unfortunately or unfortunately, he asked me to be part of it. What happened then was part of a reflection on the fact that we don't really know very much about how to diagnose diabetes, whether it's type 1 diabetes, type 2 diabetes, gestational diabetes, even monogenic forms of diabetes. And if you don't really know how to diagnose it, how are you going to treat it? And how are you going to predict what the outcomes are going to be down the road? Or how can you decide, based on someone who presents with diabetes, if that person's going to have end-stage renal disease in a year, or if they'll never have end-stage renal disease? So this is sort of a reflection of what we've been doing over the last 5 years. This Precision Medicine and Diabetes Initiative has really 5 pillars, in a sense: precision diagnostics, precision prevention, precision treatment, precision prognostics, and precision monitoring. All these are pieces of how one thinks about defining individuals or populations with respect to diabetes. In terms of precision diagnostics, we basically presented a consensus report a couple years ago that really looked at all the different pillars, but for precision diagnostics, it involves epidemiologic evaluation of individuals in a population. We brought together individuals from North and South America, the EU, the UK, which I guess is not part of the EU, Africa, East Asia, South Asia, and talking about what is it you would do for someone with suspected of diabetes. It's very population specific. Even the tests that would be ordered is population specific. In part, it's because of the prevalence, that form of diabetes in their population. So what people have been thinking about is a probability-based model based on clinical features that can be easily obtained to try to cluster people into different groups and then have the diagnostic testing specific to those groups. For prognostics, the whole idea is that we have different clinical environmental characteristics with a predictive algorithm that can decide whether someone is at risk for cerebrovascular disease, eye disease, heart disease, kidney disease, nerve disease. These are patient-centered outcomes as well, because a person may or may not want to carry out the recommendations of their physician. And so you have that behavioral aspect. Monitoring is an important aspect of this. Right now, in terms of type 1 diabetes, CGMs are really important. And CGM information can be sort of integrated with other types of information to get a better idea of risk. Precision prevention, precision therapeutics, all these aspects, risk factor avoidance, if we knew what the risk factors were, lifestyle interventions, behavioral interventions. Monitoring is a huge part of this to understand what happens to the physiology over time. What's the efficacy of treatment? Obviously pharmacogenomic information, but other types of information as well. And how does one minimize side effects? So these are all aspects of what we've been looking at. One of the things is prioritization. How do you prioritize? How do you decide for specific populations? And population, not on a large scale, even on a small scale, you can use the data to really drive the information on recommendations. So we've really identified a whole series of I wouldn't say it's a virtuous cycle, because in some ways I'm not certain regulatory engagement is virtuous, but at least you have a cycle where you have to go from the health disparity assessment, health economic assessment, clinical translation, stakeholder feedback, capacity building, research, regulatory engagement, evaluation of real-world evidence, clinical trials, stakeholder education, regulatory approval. All these aspects have to be part of how one deals with precision medicine, but also precision population health, ultimately leading to societal benefits. So we've actually engaged over 170 investigators across the world to do evidence-based evaluation to understand what are the gaps in knowledge. And there are significant gaps. It's just almost impossible to think that a 25-year-old, fairly lean, comes into a clinic and is on 3 type 2 diabetes drugs because he's 25 and not 15, which might be type 1 diabetes. You do a polygenic risk score for type 1 diabetes and it's off the chart. They've been using the wrong drugs on this person simply because of the way he looked. So these are the types of ideas that we need to be able to evaluate in populations. And so I'm actually going to stop and just thank you for listening, but also just let you know that this Precision Medicine and Diabetes Initiative has a series of individuals involved at the executive committee, but we have 175 members across the world doing this. And I think the take-home message in some ways is that we really need to have integrated opportunities so that people from diverse groups work together to really determine population health from the epidemiologic, behavioral, technology, omics types of communities. And this also applies to precision medicine. So I'll stop there and happy to take any questions because I can talk forever.
I'd like to push you on a question of precision health versus precision medicine. And so the focus that you have, from my view, from precision medicine is more from genomics and then expanding out, versus precision health is going to bring in many more factors like mental health and behaviors and social aspects. And obviously you are addressing some of those issues too. So that do you see that if you could take into account all of these other factors, how it would benefit, say, diabetes, right?
Yep.
And so I see that this kind of meeting today is trying to focus, in my view, more on the precision health than precision medicine, but there's tremendous overlap.
Yeah, and the thing that we think about in our group is that essentially having as much data as possible, whether it's genomic data or behavioral data, physical activity, various dietary aspects, getting information just from some aspect of clinical evaluation can help us determine who in the population is at risk of developing a disease. It's never going to be 0-1, right? It's always going to be shades of gray, but you also need to have that aspect of decision support within a health system or a population or a public health system to help decide who is the best individual to intervene on and what's the intervention appropriate for that person. And so I think that part allows us to increase public health as much as it will allow us to improve medicine and the treatment. At least that's sort of perhaps a naive component, but probably the harder part is deciding what are the data points that you actually need to do it, and how do you engage the entire population so they'll give you those types of data. And I'm really looking forward to the reception, not just for the wine, but for the discussion after this.
Great. Since I pay Lee a great bribe, I'd like to thank him for acknowledging the Cancer Center. And I think I'd like to follow up on that. I think the Cancer Center is a great framework for exploring problems in precision health. So, in large populations. Okay. Which do I push for the next slide? Right there? Nope. This thing? Okay. Great. So, we've enjoyed being the first comprehensive cancer center in Virginia now for almost 13 months. Just to give you a little bit of background on that, it's an extensively reviewed 1,300 plus page application involving a site visit that lasts for about 3 days. So we've certainly validated all our work. We have about 35 different categories that are rigorously reviewed. And the main question they ask is, how has the Cancer Center taken maximum advantage of the strengths of the university to address the population that we serve and keep them healthy? I would like to point out that 2 of the major components of being comprehensive involve an actual scientific program in population health, but also involvement in the community. Both of these were relatively new, if not entirely new, for UVA Cancer Center, and they were really the linchpin for success for our comprehensive grant. So across grounds, we're organized by having several hundred members in 6 different schools, taking advantage again of the strengths of the university. You heard the term catchment area. I think this is really important for our population that we serve. It's defined here. It's about 87 contiguous counties of Virginia, West Virginia. Also, the emphasis on rural health is really important. So we have a very large rural health population that's rigorously defined geographically. It involves probably more than 1 million people. It may be the largest cancer center in the country in terms of a rural population. They're very underserved and at risk for a number of different cancers. Shown on the bottom and the right, all those red spots are hotspots for cancer that are increased in our catchment area compared to the entire country. Okay, so a key question was, how can we use the tools of precision health to improve outcomes and reduce disparities for our communities that we serve? And there's a number of tools available, of which you heard, omics, computational tools. So really importantly, I think, is establishment of cohorts. You already heard that theme. We've established cohorts in our catchment area, particularly in Danville, where there's a high incidence of colorectal cancer in blacks. You've also heard the term epigenetic aging. It turns out that we have
really nice data that there's epigenetic aging in the right colon in African Americans in that area compared to Caucasians. That adds to the risk observed for colorectal cancer. And then really importantly for a success of an initiative like this is we have rigorous community engagement that's lasted over a decade. And this is a key component now that's rigorously evaluated by the NCI. On this slide shows the community engagement. It's very tightly organized with 150 community partners, including other health systems throughout Southwest Virginia. We have over a decade experience of having people on the ground, if you will, down in Southwest Virginia, working with University of Virginia with assessing needs for cancer risks, cancer screening, but importantly behavioral interventions, often using the tools that Lee described. And so this is a very vigorous network with extensive community engagement. So I'll just conclude that we would like to participate in an Institute for Precision Health with the objective to dramatically improve outcomes and eliminate cancer health disparities or population health disparities in the next decade. And I'd be glad to answer any questions anyone might have. Thank you. Yeah, Fred.
Yeah, Tom, a really interesting presentation. So my question is, within this really broad framework that you have established, do you see a role for technology? So I've got my engineering hat on. And so do you see a role of data collection, sensors, other types of technology collection that can be deployed across this catchment area?
Yeah, definitely. That's an advantage UVA has for sure. And our site visit, when they reviewed the population health program, actually called out Lee Ritterband by name, which is extremely unusual to highlight one individual amongst the whole team. But it was extremely well reviewed in terms of apps and health, and certainly sensors will be a key component. We haven't really taken advantage of that at all, but obviously there are environmental causes to cancer that sensor technology could help elucidate beyond smoking and obesity, which are the two biggest problems in our catchment area. All righty, thanks for your attention.
Okay, thanks, Karen, and thanks for the chance to talk with you a little bit about. We were fortunate, and I'm actually not realizing, or I didn't realize the size of the screen, so I hope everybody can see that. But if not, I'll talk you through it. But we were fortunate to be able to be a group that was selected last year for the initial P2PE in precision medicine. So we're really glad about that. And I want to talk to you a little bit about our program, a little bit about our progress in the last year, and then a little bit about what we learned and what my thoughts would be about going forward in this domain, this more biological domain of precision medicine. So our P2PE, or Prominence to Preeminence Award, is entitled Precision Immunomedicine, or I prime, and the I comes from our focus on immunology, imaging, and informatics. And that is for, we also focused it on cardiovascular disease, and again, as you'll see, that's not what would be my long-term vision. It would be more broad than that, certainly, but just getting it shored up, I think we had a lot of technical and managerial readiness in that sector, so we stayed focused on cardiovascular. We proposed to build an ecosystem to catalyze interdisciplinary science, to train the next generation, and to identify ways to enhance the precision of clinical decision-making in cardiovascular disease using immunology, imaging, and informatics. So kind of the problem that the societal, if you will, problem that we're really trying to address is that despite our current technology and knowledge and healthcare and outstanding care providers, there really is a big gap in terms of our ability to actually make precise diagnoses, prognoses, and even make precise therapy selections for our patients. So
bringing in more precision medicine is really going to enhance that and have a great impact. And it has a couple areas where it's an issue, is when you're even trying to diagnose a given individual. Many people have subclinical development, and particularly in the cardiovascular sector. It's actually half of all heart attacks are unheralded sudden death, and it's because you don't even know that you're sick. You think you're healthy. So we do need more precise ways to kind of get at that, I think, in healthcare. The other issue in healthcare is we do the best we can. We do large randomized placebo-controlled trials to determine what medication based on certain inclusion criteria for the patient. And then when we get a p-value, it's you go to the FDA and see if you can get approval. However, not all those people benefited from that drug because we enrolled 10,000 people, and so sometimes even more than half of them didn't really benefit, some harm, and these drugs aren't cheap. So that's really another critical unmet need in clinical medicine where precision medicine can really bridge that gap and have a big societal impact. So why did we focus on immune cells? We've heard a lot about genomics, and my good friends Steve and Charles Farber know a whole lot more about that than I do. But we've really focused on immunology, although as you'll see, I think we need to be pulling genomics in to be sure. Because the immune cells have really emerged as being really important in many diseases. And in particular, they're emerging as being really important in heart attacks and heart failure. And yet we really don't have good therapies for using them in those ways. And, along the lines of the title of our project being Prominence to Preeminence, we have a real opportunity to be preeminent in that sector because there really isn't anybody in the nation that really has the combination of things that we have with the technology, the data science, the research data commons, the immunology expertise in our cohort. So. The other reason is immunomodulatory therapies are actually the leading drug being on the market or being growing class of drugs today. We with the ability to really dive deep and study the immune system through some of our technologies, which I'll touch on, or you can even see up there. The orange box is a mass cytometer called CyTOF. It's a large instrument that we have in the core that's very, very expensive, and with the P2PE, we were able to upgrade actually to instrumentation that now only UVA and Dana-Farber have that allows greater automation, greater efficiency of the system. So our ability to deeply interrogate the immune system and the importance nature of the immune system in disease and now emerging in cardiovascular disease is why we focused it that way. So what's gone on in the last year? Well, we renovated space. We, as I said, purchased this enhanced technology. We've recruited an outstanding team of clinical research coordinators, lab specialists, bioinformaticians, and we've been able to assist more than 20 faculty from diverse disciplines across schools and across different departments in the School of Medicine in precision medicine work. We're populating our largest cohort, which I'll tell you about, into the research data commons that Don Brown and Joanna Luma and others have developed, which has been really outstanding because it's going to allow us to share our data with all of you and anybody else who would like to access our patient population. We've also awarded $400,000 seed grants, and again, this is required that these two investigators come together and that it be interdisciplinary. We favor when it's two different schools, and we do have some of our recipients that are in that category, but even if they're all within, for example, the School of Medicine, they have to be from different disciplines in order to be competitive for the award. And we're currently launching a fellowship program. So some of our deliverables, if you will, and some of our unique features. I mean, we have a cohort of subjects that we're putting into the Research Data Commons that is 800 in number. And we call them the CAVA cohort, and that stands for Coronary Assessment. So that's your heart artery, your coronary artery, Coronary Assessment in Virginia. So we call them CAVA. And for that, in that CAVA cohort, we've also cryopreserved their immune cells, their DNA, we have their RNA, we have circulating capacity for circulating biomarkers. So as Jamie and many others were talking about, the value of merging all sorts of fields like health with biospecimens is really another exciting area. And for within that cohort, which is very unique to UVA, to have not only that type of advanced imaging, but to have all those biospecimens. And much to the dismay of my lab manager many years ago, I was insistent that we freeze back 30 tubes, and he thought I was a little crazy, but now we're pretty glad we have those 30 tubes, and we're big into sharing if anybody's interested. And that's another part of the P2PE you can apply to get our specimens. So we've had several high-impact publications in this cohort in the last year. We've also successfully been awarded a transatlantic network of excellence. So this cohort has been able to put UVA on the global stage. So there's 3 of us in the U.S. and 3 of us across the pond in Europe that are collaborating, and it's this cohort that attracted them to include us in that grant. We also have a program project grant that uses CAVA as well, and again is supported by the P2PE, and that allows us again national interactions because it's multi-institutional. Another, although he doesn't like me to call him a deliverable, so I told him, okay, you're a milestone, but we did promise we would recruit in a clinical trialist doing immunotherapy for cardiovascular disease. And this is not very common, again, it's very unique to UVA. And we were able to get Dr. Antonio Abate. He came this summer. He's already enrolling. So if you or anybody in the community comes to UVA with a heart attack, you're going to hear from Dr. Abate and his research nurse to see if you'd be willing to be enrolled in immunomodulatory therapy. But not until I' gets the blood sample. So we want to be able to, again, samples before and after, so we can develop precision approaches to figure out who might be benefiting from these therapies. And then we have another very unique to UVA, and many of you may even have familiarity with this, alpha-gal syndrome, which is also called meat allergy. So we have a big cohort in that because the Lone Star tick is in our area, as you know. And so we've actually found with our cohort that if you're sensitized to alpha-gal, you have more heart disease. Not just about 5% of people or less will have meat allergy. A much higher percentage of people have heart disease. So that's been an exciting cohort for us as well, and we've had publications. We've also been able to seed a collaboration between immunology, dermatology, allergy, and cardiovascular with one of our seed programs. And then Lauren Erickson in immunology is the contact PI on a multi-PI $4 million grant that we got this year that started in the summer. So we've been very happy, very grateful, and it's really been a lot of fun. So can this ecosystem serve others? Because that would certainly be our vision, and we've heard a lot about all the different areas, not only precision medicine, but precision health. And again, we are developing an ecosystem that makes it easy brings people together and makes it easy for you to get the biospecimens and perhaps easy to get other expertise. So we certainly think that we can, because the immune system is important, again, in so many variety of different diseases, and actually just important for your general health against warding off, as we know, viruses and in pandemics and other types of viruses. So, one of the things we thought would be interesting is to consider expanding this ecosystem to support other areas and support even health. In addition, To immune cells, though, I think another thing to kind of think about is some of the other things that people have talked about, waveforms perhaps, genomics obviously, and the microbiome, which is really emerging as being a very important determinant of health. And so to be able to then, instead of replacing the inflammation with these pictures are genomics, microbiome, immune cells, and even waveforms, to be able to really move forward and collect all of those data would be really powerful. And then consider enhancing, again, team efforts and skill and workforce development. So this is my final busy slide, or the next one's busy, but I'm not going to talk about it. So to meet the grand challenge for more precise and personalized healthcare by targeting areas at UVA with great promise for preeminence, I think that there's a lot of opportunity to broaden out. We've been, like I said, we've been really happy with the enthusiasm for this platform that we've had, and really would like to broaden it out, building on prior investments such as the Trans-University Microbiome Institute, many other prior investments, the strength of our thematic centers, including the Cancer Center and the Genomics Center and many others, iThrive. And then teaming actively across schools like we do, again, to really build collaborations, to provide opportunities for our trainees. And, as you can see down here are the different things I think that we could collect. So we're going to end up with an enormous amount of data. So we're going to need the help from data sciences, AI, because we're going to need to do really multimodal integrative analysis and multimodal explainable AI, and as Adong Zhang does, who's been a big collaborator with us all along in both this P2PE and some of our other endeavors. So we just think that it really would be very important to harness the fundamental discovery in big data in all of us, so all our biospecimens for precision medicine and health. And this is my last slide, but I know I'm way out of time, so I won't list out these names, but it really takes an ever-growing team, and watching our team grow has just been so exciting and inspiring for me. Watching people come together from across schools that never really knew each other before, sometimes don't really even understand each other's language entirely, but we know we have to in order to make this happen. So that's been awesome. And then the iPrime team, which is down in the right-hand corner, is the individuals that we specifically recruited through the generosity of the P2PE program. So thank you very much. Questions for Dr. McNamara? Steve.
Okay, I've got a microphone. It strikes me that given the importance of the immune system, in many ways, it appears that we should be thinking about across the lifespan, because obviously, we haven't talked about it, and I haven't, but since I'm old, I can talk about Alzheimer's. But certainly there's immune aspects there as well, and so it seems like we should start thinking about sample data collection, not only cross-sectionally, but longitudinally across the lifespan.
Yeah, that's a really good point. And I didn't focus on it, but we have several ways in which we image. And we do have some patients that we're coming back and re-imaging so we can look at progression. But in the cohort that we recruit, we do have broad ranges. So we had a seminar speaker come in from WashU, and he's doing single-cell RNA-seq across the lifespan and needed a second cohort. So we just FedExed him our cryopreserved PBMCs for him to look at that, because the immune system definitely changes with aging. And that is a really important component to learn more about, because of how important the immune system is, like you said, in infections, all sorts of diseases.
Thank you so much for your presentation. It sounds like there's a lot of people and a lot of moving parts that you all have been really successful in coordinating. Could you share some of the organizational or administrative sort of structures that have allowed you all to be so successful?
Well, thanks for that question. We're just really grateful, and we value everybody. And I think that's one of the things that has helped us be that successful, actually. It's a multi-PI. It's myself, Stefan Bekaranoff, and Angela Taylor, but as I said, many, many others. And we have a weekly meeting with the whole staff. We also then invite investigators that are interested in using iPrime resources to come and present their science to the group, because it's so helpful for the group doing the work to actually see, for example, Sid in kinesiology came and asked us if we'll get, blood on his patients that he's treating with exercise prior to breast cancer treatment. And it's meaningful. It's really meaningful for the group to see the application of their hard work, because it takes 4 hours to process these samples. Sometimes people have to stay late. We have to send people over to consent. We have to fill out the 37-page IRB. They're doing a lot of work, and so it's really meaningful. We bring the reality of what the project is right into the group doing the work, and we do a lot of teaming. We think teaming is really important to making it happen, and I hope that answers your question.
Thank you. And I guess I want to say, the presentations have been fantastic, and what I'm going to do is I'm going to argue that we are an enabler for everything that you've heard before us. We're going to be an enabler for the kinds of things that we're talking about. And thank you, Colleen, for the shout out. I really appreciate that, and as an introduction to what we're talking about here. So what we're suggesting is a UVA health data enclave. And I'm going to argue that this UVA health data enclave builds from strength in 3 specific areas. One is the Integrated Translational Health Research Institute of Virginia, or iThrive. This is centered at UVA, but we have partners, and the partners are at Carilion Health, at Inova Health System, and at Virginia Tech. We also have collaborators with the Center for Open Science and the Licensing and Venture Group. And I'm going to tell you a little bit more about iThrive in a minute. We also have the iThrive Research Data Commons, which Colleen gave you a little brief introduction to. This is, in fact, a cross-state harmonized infrastructure that allows research, resource discovery, and it allows for research data workflow sharing. So it's a very powerful tool that we built here at the University of Virginia. Again, I'm going to tell you a little bit more about it. The third strength is actually an international collaborative. It's called the Observational Health Data Science and Informatics Collaborative. Now, this is a bit of a mouthful, but what this is a very broad range of international collaborators, again, in the United States and overseas, who have gotten together with the mission of trying to say, how can we use health data to improve health? And what they've done for us is they've built a common data model. This common data model, which goes by the acronym OMOP, is a way for us to share electronic health records regardless of what the vendor is for those EHR, okay? Regardless, we can harmonize the data effectively. So those 3 strengths give us the ability to create what I'm going to argue is a transformative solution to this grand challenge. Okay, I'm going to say a little bit more about iThrive now. iThrive, like Tom said about the Cancer Institute, it's a gigantic proposal. We're going in against amazing competitors from across the country. There are only 60 of these in the United States at any one time. It's a 5-year award. We're in our last year of the award. We've got our new proposal submitted after months and months of work. It's a big effort. We've submitted that in January. We have one other regional hub in the CTSA. They're a partner with us at VCU. This is a very, very powerful, prestigious award that we've got here at UVA to do this kind of thing. Data science to health is one of our goals. Collaborative teams, another one, and training the next generation. We're looking out to the future when we think about what we're doing in iThrive. And like Tom said in the Cancer Institute, we have an incredible reach. What I'm going to argue with you today is our proposal is beyond the catchment area of UVA. I'm going to argue when you talk about populations, you've got to go beyond UVA. What we've done in iThrive is we reach, as you see, from Southwest Virginia all the way up to Northern Virginia. Now, this is the rural part of the state, all the way up, and I guess I was told it's not urban up there, but suburban part, whatever it is, that dense area in Northern Virginia, we've got that. Okay, we got it now. If you look at the sites that we have in our system in iThrive, we reach out and touch 60% of Virginians, okay, right now. And I'm going to argue we can reach further. The other thing about us is, again, like the Cancer Institute, we have an incredibly strong network of community collaboration. We have community collaborators throughout the state that allows us to reach into communities and answer community health questions, not the questions of the Academic Health Research Institute, okay? We're looking to communities for their questions. What's of concern to them? Okay, there's a lot I could say about the iThrive Research Data Commons. This is my love for the last 5 years. It's a great project. It's fantastic. You can think of it as basically a cross-state harmonized infrastructure for research discovery, and it ensures compliance because we're working with protected health data. We heard the talk about what we want to do to protect data. By gosh, we want to protect data. We want to respect privacy. We've got to do that. Our infrastructure creates the foundation for doing that kind of thing, for secure analysis of data, of EHR data, to address all the problems, the great issues that you've heard in these previous speeches. We've got the infrastructure to help address those questions with that important data. We also have collaborators from across the university. 6 colleges in the university right now collaborate with us either in the use or the development of the iThrive Data Commons. And I also want to mention finally that, as is shown here briefly, we're not just about protected health data. We can work with de-identified data, public data as well. Bring that in where it's important to use it. We can generate it, we can bring it in, we can integrate it. Okay, this is the vision I have for, I shouldn't say I have, we have for the Federated Virginia Health Data Enclave, because this is a big team of people that we've got. It's not just me, and some of our teammates are here today. What we're talking about here is the ability to create an infrastructure that creates for federated use of data, of protected health data. This is a very powerful concept. The big change that we will bring is we'll bring in those open source analytics that are available through the Odyssey infrastructure. We'll bring that in to our landing service in the iThrive Commons. And we'll be able then to give people, the ability to go from one institution to the next. So let's take an example. Pick any one of these things you heard today, okay? I'll pick cancer. And say you got a cancer researcher at UVA. They've got an important problem. They want to pull up that EHR to address that question that they're looking at. We can do that at UVA, and oh, by the way, we can look at a colleague in Centera. They can do exactly the same thing, create the same data infrastructure for them, create the same analytic infrastructure, share those results. That's enormously powerful. We're talking about a population-based look at what we're talking at these questions that we've heard today. Oh, and I also want to mention, thanks to Teague, there's nothing in this that says that you have to be in Virginia. You can be anywhere. You can be anywhere in the United States. You can be anywhere, frankly, in the world, and we can put down that landing service with you. We've already been asked by the University of Colorado, for instance, to get a copy of our research data infrastructure, okay, our basic landing service. They've been asked, and we're in our contract negotiations with them about that. So there's nothing in this that is fixed to the Virginia as a place to be. So when we talk about population, again, think big. Think about a bigger reach for that. Okay, I finally want to emphasize, thank you. I finally want to emphasize we are best in class. We're already recognized as national leaders in data science for health. Through the National COVID Collaborative, we addressed questions with 17 million individual patient records. We looked at questions related to COVID on maternal health, questions of heart disease, questions of stroke, questions of health equity. Our first speaker absolutely focused in on those kind of questions, and we addressed them. If you look, we are considered a center point for work in this area. More than 200 studies have used the templates that we built for these data in order to address these questions. So I guess I want to conclude with the words by a colleague and friend, Bill Wolf, a faculty member, an emeritus professor from data science. He called this unfair competitive advantage. And by that, what he meant was, he was trying to get UVA to think about ways that we could create capabilities that would give us the ability to compete with anybody in the US over when we go for these research grants, that nobody's going to be able to compete with us because we've got this capability. And I'm arguing that if we create this data enclave as we've described it here, we will give any of my previous speakers the ability to compete with an unfair competitive advantage. You'll be able to go out and compete with anybody because of this infrastructure that we've provided you with. And I think that's the route I can see to preeminence, is that kind of infrastructure. So thank you.
Hi, Don.
Hi, Don.
Excellent talk.
Thank you.
I want to ask you, you look at the ChatGPT, it's so popular right now, but it has been there many years, actually 5, 8 years, people did not know. Now, it recently becomes popular. It's because it can write essays for people, right? That's the unique thing, make it so distinguished. So I like to ask you, kind of system you describe is excellent, but nationwide, there are other places also develop a similar system. And you mentioned the data, right? Data is the most important part. I think it's the foundation of this kind of tools. But I like to ask your vision, what is, a unique feature to the end user you will finally provide?
Yeah, thanks. So I guess that there are a couple answers to your question. First one is, actually there aren't, when you look out at the EHR systems, the systems that support pulling data from the EHR, it's not true that there are multiple systems at the equivalent level of what we're describing in the iThrive Data Commons. In fact, that's one of the reasons why we won that first award without any kind of resubmission, is because they looked at it and went, oh my God, this is incredible, this data science approach that you're taking here. And we still remain, I would argue, we remain at the lead of that. But I'm arguing that if we can incorporate these analytic components, which includes components from AI, for example, in machine learning, in that analytics infrastructure, if we can incorporate that within that landing service capability that brings, the results of the harmonization process through it, that piece of it is, that will just extend our lead tremendously with regard to that capability. Now, what does it do for the individual investigator? Well, there are a number of things. As I described, you could take an individual investigator here that's looking at any one of these precision health areas, and it gives them the capability to work more broadly than within, I'll call it the UVA catchment area. You can look at this broad level of population health across a much greater set of collaborators than you're going to get out of just one focused area from this area. The tools that we have, in terms of the, the user friendliness of the tool, we have something called the iThrive portal. That is an incredibly nice front end. A lot of people like that front end and use it for a lot of things. That's where we bring everything through. And we're constantly looking at user friendliness and adaptability of that portal to make it more friendly for people to bring what they need and to get what they need out of it. So I don't know, it seemed like you asked me multiple questions. I hope I answered them all. Yeah.
I had a question.
Sure,
I think this is not really you're talking more about we have community access to data. What about, how are you thinking about data acquisition and real-time analytics? Because this is something that I didn't really hear about
No,
and that we need
You're absolutely
desperately.
No, you're absolutely
Yeah.
right, Laura. I'm saying I'm going to be an enabler. I'm going to enable like what you and Lee talked about. You're going to bring that data in, but you're going to want to. It's not that you're going to say, okay, let's take these sensors, put them on a person. You know, I've got my Apple Watch on. I'm tracking and I'm doing all that kind of stuff. That's fantastic what you talked about. But that data is going to have to get linked with the EHR. You know,
It
you're
is,
gonna
but
wanna-
I'm asking,
and that's
are you
what
thinking
that's what I'm
larger
talking
in
about.
infrastructure?
What's that?
Are you thinking larger in terms of infrastructure, data acquisitions,
I'm
or
thinking
more post hoc, linking it to EHR?
Correct.
Okay, so I wanted to ask that because that's an area of need. So
No,
yeah.
I'm not disagreeing. That's why I say I think what you and others have talked about spot on. But I'm arguing that you got to have this enabling piece that we're describing here to get you that
Oh,
final
I agree.
lift that you're
Yeah.
going to want to get.
But I
for,
wanted you to answer me that other
Yes,
does not
it's
exist.
important. It's
So,
important.
Yeah. Okay.
This is really exciting. I just wanted to ask, one of the challenges with EHR data is our fragmented healthcare system.
Correct.
And so a lot of what we want to see doesn't reside in UVA Health or Centera or any of our partners. Do we have plans for gaining access to data that might reside in private EHRs, federally qualified health centers, state vital statistics? Are there any partnerships we can do there?
Yeah, the last one you mentioned, absolutely spot on. The first ones, I'd say that's, next steps beyond. If we can do this part, I think we can start thinking about those. But the state one, we're in discussions with them now. Absolutely.
That'd be really exciting.
Yep.
Yeah.
Yeah, T.
Could you speak a little bit about hybrid use as physicians recruitment?
Yeah, you could use it for that kind of thing. And in fact, there are people that do. She doesn't want me to call on her, but I mean, I have an expert on, clinical trials there that can speak more informed than I can about recruitment capabilities from it. So Karen,
Yeah, so we do have cohort discovery tools. Those are available across the country. Most sites have them, but what we're able to do is integrate cohort discovery pieces again across the population. So yes, we do have much better cohort discovery tools now than we've ever seen before.
Great, thank you.
Thank you.
All right, thank you everybody for sticking through the afternoon. So after we've all been sedentary for most of the past 3 hours, I'm going to talk about physical activity. I want to start out with a question, which is, how many people in this room have exercised either yesterday or today? Okay. What do you think the proportion of patients who had an appointment with the UVA health system today, how many of them do you think exercised in the last 48 hours? Okay. Why? Why the disparity? Okay. Is it education? Is it socioeconomic? Is it the neighborhood or the community that they live in? Okay. So these are all factors that I think we need to be considering. So what I'm going to propose is centering physical activity at the center of precision health for populations. So I want you to imagine a university that places physical activity, mobile health, and the advanced quantitative methods to study those things at the center of health research, education, and patient care. And to imagine a healthcare system where every patient, provider, and counter addresses the patient's physical activity and mobility. In a healthcare system where every patient's treatment plan includes a personal physical activity prescription that isn't just, a national guideline of a certain number of minutes of moderate physical activity per week, but actually gets to the point of how can that person exercise, okay? And then lastly, imagine a university where every health profession student, resident, fellow is trained to center physical activity and mobile health in their patient encounters. So we know that there are dire consequences of physical activity. So I've cherry-picked some statistics here from the CDC, but we know that inactivity contributes to 1 in 10 premature deaths. I'm not going to read every statistic there. You can read those yourselves, but that inadequate levels of physical activity are associated with, estimated $117 billion in annual healthcare costs per year. And I think this stretches across everything that we've been talking about today, from mental health to cancer risk to cardiovascular and other things as well. So when we think about a precision approach to physical activity prescription, I think we need to consider both the individual factors as well as the community factors. And this is not just the factors of what can make somebody more physically active. It can also be on the aspect of what type of physical activity are they going to best respond to. So just like we're talking about pharmacology being linked to omics, we can also think about how physical activity is going to be linked to omics as well. So we can use this kind of international classification of functioning idea of the personal factors and the environmental factors, but we can use that in the approach not just of pharmacological and surgical interventions, but also in terms of physical activity interventions, with really the goal of thinking about meeting patients where they are when it comes to physical activity. So again, getting beyond that, here's the blanket prescription for everybody, but thinking about what is going to be best for each individual patient, but also thinking about how is that person actually going to become physically active and then stay physically active? Because if we think about this of just telling patients 150 minutes of moderate physical activity a week, okay? For some patients, that is the same as saying, here's a prescription for a drug that's going to cost $500 out of pocket a month. That prescription's never going to get filled, okay? So I think we need to be thinking about community health experts, and other types of social programs that give people the opportunity to be physically active and to stay physically active in an effort to improve their health. So when I was thinking about this in terms of how can physical activity be centered for precision health for populations, I think kinesiology and public health are at the center of it. So kinesiology in terms of being the physical activity and exercise experts, and public health in terms of being the health promotion experts, the population health experts. And then on one side, you've got your clinical disciplines, and the other side, you have your academic disciplines that work together. Don't be upset if your clinical or academic discipline isn't on here. I only had so much room. But the ones that I list there, cardiology, endocrinology, musculoskeletal oncology, I put those specifically because we've got a good history of doing supervised exercise trials from patient populations in those disciplines. And to me, that would make sense that we try to build on those strengths already, but extend that beyond supervised exercise trials that have largely had physiological outcomes, but expanding those into community-based population health level outcomes. And then on the right side here, you look at data science and engineering. We've heard great things about data analysis, data wrangling, data management, data collection as we look at sensors and mHealth being important. Disciplines like psychology and education, thinking about how do we use things like motivational interviewing to improve compliance, but then also things like architecture and public policy when it comes to the built environment to allow physical activity, and public policy to incentivize physical activity in certain ways. So what would be necessary for success? I think first is the cooperation and commitment to interdisciplinary research, education, and clinical care. And I think that's why we're all here today. Second, I look at investment in scholars who have expertise in physical activity promotion at the population level, clinical trials experts when it comes to community-based physical activity interventions, and then those with expertise in mobile health, advanced quantitative methods, clinical translation. This is going to require community-based health promotion experts, and then obviously we'd look to seed projects that place physical activity and mHealth at the center of precision health research. As I said earlier, I think there's certain medical disciplines that make sense based on our past history of success in those. And then I think a big thing that needs to be decided is, what do we actually mean by population? So we talk about, yes, we all want to improve societal health at large, but when it comes to where we're actually doing trials, what are those subpopulations that we want to focus on? And I think health equity has to be central to that. And then how do you sustain this? You know, obviously extramural funding, philanthropy, community, and industry partners. So thank you very much.
How do you foresee compliance fitting into this? It takes, I know for a lot of the trials, for a lot of the trials, you know, there's some initial gains, and then as soon as the staff go away that help motivate them, there's that compliance issue.
Yeah, no, absolutely, and like, you know, I can kind of speak to my expertise in like musculoskeletal rehabilitation, and yeah, when patients are going to physical therapy, they're doing the exercises, they're responding to that. I think that's where we look at the community aspect of this, and thinking about the social connections in terms of people that are physically active tend to be around other physically active people. And I think we've got to think about that in terms of, okay, everybody in this room, you know, has the connection to our academic institution, but how do we place that in, you know, other communities that aren't necessarily going to have that same culture? And I think that's really important. And that's where I think, you know, when you look at technology and the aspect of like behavioral modification, not just around physical activity, but also around other, you know, diet and nutrition and other lifestyle choices, I think that has to come into play as well.
Yeah, so that was great, and I had mentioned we're working with SID, so of course I'm interested in your thoughts about the role of collecting patient biospecimen and perhaps exercise, and actually there's data, as you know, I'm sure, that exercise improves your immune system. Yeah.
Sure, you know, absolutely. I think you know, that really comes into the part of the precision aspect of this, when you look at like which individual patients are going to best respond to different types of physical activity interventions. We absolutely need the biological work in those areas. Sid sends his regrets. He's at a conference today.
So this is far from my area. So my question is, in terms of uniqueness, I like the idea of putting physical activity at the center. And is that happening many, many places or nowhere? And that we would be very unique in this?
Yeah, so for example, the American College of Sports Medicine has used the slogan "Exercise is medicine" for at least a decade. I would say conceptually, people like the concept, but when it comes to actually having the kind of boots on the ground, we're really trying to make changes in this area. There's a lot more work that's being done with kind of, you know, laboratory-based studies of supervised exercise, as opposed to actually getting out into communities and thinking about how patients can actually sustain exercise for a longer period of time.
So the NIH has invested about $170 million in a protocol called MotorPack, Molecular Transducers of Physical Activity, but theirs is a one-size-fits-all, exercise prescription. So it's across the lifespan, but it's standard aerobic exercise or standard strength training. And it doesn't really look at the precision approach. They're going to look at the omics data and then hopefully build on that to get more precision intervention technologies. That study is probably about 3 or 4 years into a 5-year data collection. So this is a really nascent area that we could truly be a leader in.
So my question is actually for all the speakers, and I heard a lot about collecting data throughout the process, which I think is important. When I come in from a data science or computer science perspective, I kind of think, how much can we keep collecting? I mean, is this a process that is going to keep going on and on? Because at some level, you need to collect a lot of data. I mean, is there a way to look at all the data that is available and make sense out of it? Because it seems like a process which is very expensive in some sense. So it's a question for all of us to think, whether this is a process that we can continue to do this, because it's a very expensive process to collect and maintain and retain.
Yeah, absolutely, and I think that the infrastructure is important. There's also the patient recruitment is important. There's what kind of technology are we using to collect mHealth data and things like that. But I think in the long term, the more data we have, the better prediction we have for influencing and improving individual patients' health.
If I might just jump in terms of the expense piece, because you're right, a lot of this is really quite expensive. And then when the support for whatever the initiative ends, is what happens? Does disappear? So I do think it would be really important for us all to be really thinking about sustainability issues and ways to make your program sustainable. And we'll see how we do, but what we're doing with everybody that we actually help, because again, we've created this ecosystem to help others, is we tell them, yes, you can access this and we're not charging you, but you're gonna get preliminary data and you're gonna write a grant and we're gonna help you with that, and then you're gonna budget the use of the initiative, the people in the initiative that you're using, and we're hoping in that way the money would come back into the system, and not only would we raise stature with getting funding, but we could hopefully keep it sustainable. Now, I hope that works. I mean, that's our plan, but that's one thing to think about.
Okay, we had, as you can see from our many charts, lots of discussion about our question that we were answering is, what are the areas across grounds that would be important contributors to a precision health initiative? Please be expansive. So, bearing that in mind, we were expansive. So, data science is a crucial contributor, and yet we note that the Data Science Institute is going to be physically distant from many of the other partners. And so there were questions about physical barriers, distance, mobility for partnerships to really work well. We also noted that we need patients, participants, and researchers in the data science area. And people noted the limitations of Zoom. At least I personally am very sick of it. Also, we want to make sure whatever data we collect complements data we might already be able to glean from existing sources, and therefore there might be a need for harmonizing data and being mindful of data security. It was mentioned that we need a higher level of analysis, and that some people missing from our room today, with a few exceptions, are people like mathematicians or math modelers or physics professors. And we'd like to add them to the conversation sooner rather than later. Somebody also mentioned, what is just the minimal data set to make a project make sense? Like, could we, instead of going bigger and longer, could we find a minimal data set that everyone collects, and therefore over time we end up with a huge data set with at least this minimal set of data points? We also noted that network access is limited in the rural areas of our state, even though many of those folks are the people we might most want to gather, for example, within the Cancer Center catchment area. We also talked about a more limited small catchment area like Charlottesville or the surrounding county, from which maybe we could glean a larger set of layers of data. So it could be biological samples, could be mental health measures that we could do very well. Somebody thought of recruiting women in our area early in pregnancy or even when planning pregnancy, and then start following her and that resulting baby forever. Less self-reported markers are wanted. We want digital technology to collect a lot of data, especially if we're going to do it over a long period of time. We talked about the sociome, which I'm not totally sure what that is, but I think it's all the social and behavioral measures. Social media layer, that certainly there's an opportunity to collect a layer of social media data from participants, the microbiome and behavioral data. Important contributors, community engagement, the Democracy Initiative. We should think about centers like senior centers, schools, fire department, police, private medical sector, the sports sector like the YMCA, ACAC, SACA, et cetera. And then we have a whole boatload of UVA resources, which because of time, I will end there and turn it over to group 2.
Okay, so our group was charged with identifying key UVA strengths that we want to leverage as we think about what the best investment is in this precision health effort. So the first thing that we came up with also was the School of Data Science, the existing cores across grounds, we want to leverage those. The unique proximity at UVA of the schools and the patients, we are in a tighter community than many large public institutions. The culture of collaboration that makes us ready to work together, the digital alliance model to enable technology, research institutes, many of which you heard from today, that focus on team science and use team science to grow their research strengths, the School of Education, community engagement resources. So we heard a little bit today about community engagement resources in some of the research institutes, but also it came up that we have pockets of really engaged community members who want to participate in research. So leveraging that. Resources to support collaboration, so we're starting to see centralized and individual groups using resources to pull people together in collaborative research. The Link Lab was called out as a strength, that we have lots of domain expertise across grounds that we can pull into whatever centralized resource we build. We have lots of domain expertise to bring in and support lots of potential research programs. The new investment in the Translational Biotech Institute, we see that as a potential strength to make sure that we're leveraging that investment with whatever we do. We have engaged patient-facing clinicians. We feel like we have the clinicians there. We just need to protect their time a little bit to allow them to participate in these research efforts. We have embedding models to grow collaboration and to grow collaborative trainees, which we thought was unique. Pockets of health equity expertise. Shout out to Keith Keene, who's now here running that institute. Public health expertise, it's a little more distributed because we don't have a school of public health, but we really felt like we have a lot of public health expertise here. We have data models that can standardize and harmonize data. We have recognition of the importance of data and technology ethics. So we talked a little bit about this, the fact that we don't really have a full team to do data ethics and technology ethics. But this is an opportunity because there's an appreciation of how important that is as we think about big data and data harmonization. Relationships with the state were identified as a strength. Pockets of models for tailored approaches to rural health. Again,
We didn't feel like we've mastered the concepts of rural health, but we feel like we have models here that really could grow and be leveraged. And then we talked a little bit about development and the fact that we have a strength in the foundation relations team that are now helping lots of researchers get foundation money, which is more flexible than traditional federal funding agencies. So did I miss anything, guys, that was big?
All righty then. So our group talked about the key resource gaps at UVA today that would need to be filled by this initiative. So a bit of a dark mirror of the actual resources. And in no particular order, we talked about just the sheer price of doing data collection for precision medicine. We talked about this mainly in the context of like mobile health and sensors, and just the you need a lot of that to get that. So doing something with that would be helpful. Another major thing that we talked about was communication and connection across grounds as a potential barrier to collaboration. And this includes both infrastructure, such as like basically data firewalls existing between various academic and administrative units, just a lack of communication and siloing. There's sort of academic disincentives for mixing various people from fields in terms of what we need to, get promotion, get all of that. And the suggestion that we had was, one, more specific interdisciplinary spaces, and that can either be physical spaces or in terms of centers, and also administrative support, specific administrative support for these cross collaborations between areas. There is, we identified a bit of a disconnect between the incentives of research versus clinical practice in our School of Medicine as possibly kind of preventing this. Support staff we identified as needed. We talked a lot about building just better community engagement, generally speaking, given the history of community engagement that UVA has had. Although, in terms of our strength, I think one of our strengths is that we are working on that as an institution. We also did talk about data science expertise and kind of modeling expertise and having access to that specifically, and having a way of researchers to be able to look up, okay, who is a data modeler or a data expert in any unit that is applicable to this sort of research. And then finally, we talked a bit about getting buy-in from clinical departments and clinicians for getting data, and how this needs to be a bi-directional relationship. We can't just ask them for their data, we also have to be able to provide them with our conclusions and with useful aspects of that, and so building out those relationships there.
Thank you.
Sorry, don't want me. Yeah. Okay, so I guess our first question is what type of collaboration outside of UVA would be needed? I think it's some overlap with what Karen has said. So, well, basically, if I summarize what the group has mentioned, I think there is a general agreement among the group, the level of collaboration between academia and the industry outside of academia with private sectors and community is important to this topic, the precision health. And with that, we needed to, actually UVA has established a lot of collaborations with private sector and industry, and so we should incorporate those into this program. So I think that's the general agreement in the group. So I will not go to details of what kind of collaboration, because Karen mentioned all those listed there. And the other question we have is what will be the demonstrable impact of efforts in precision health and over what time frame? What specific populations will benefit from the work? So that is a bigger question, comparing with the first question. So in general, we first actually discussed among the people what do we mean by precision medicine, health? Because a lot of speakers have talked about precision medicine, but I think the goal here is precision health. It's, is it including the medicine, or is it outside of medicine, or is it a broader range of that? I would say it's a broader range, comparing with precision medicine. So with that, I think for precision medicine, health, see, I make a mistake too, because, we are used to talk about precision medicine. And so with that, precision health is more broader, and we need to go, more preventive way, not just with patients, with the population level. So I think we talk about UVA has advantage of students' health databases, which will represent a broader range of different features, different populations, because the students are coming from all over the world. So that may be an advantage for us to build a population level database to start with. So that's what I think many people in the group agree. That's a good foundation for us. So it's unique for UVA. Then what else I missed? In terms of precision health, again, we are talking about all the EHR records, which are the most important parts. But I think the last question when people were asking questions, last question was, data is expensive. What's the point to collect it, and what range? So this question I actually asked my group because I'm a computer scientist and working in AI. So what do you feel? I actually want to ask everybody. What do you feel about synthetic data? Because I actually heard a workshop just recently, National Academy of Engineering held a workshop on digital twins, which actually there are panels and speakers talking about generating data based on existing data. And so with the complexity of machine learning models, we can generate a very good synthetic data to mimic the complexity of existing data. So I actually asked a group, some of the people actually think it's maybe a good way to improve the ethics, privacy, because measuring data takes time, costly, but with synthetic data, we could simulate to certain complexity to mimic the population data. But I know NIH is very careful, now, encouraging simulated data in genomics level, maybe that's the problem. But I just hope to get a feeling because the world will, you have, like I said to the steering committee, and you have ChatGPT, eventually you will have, actually somebody called me the other day, are you interested in building a bio-GPT? And somebody else, how about health GPT? So this will appear sooner or later, very soon. So are we going to, this may have unique features. Are we going to have something unique out of UVA, $50 million, a big investment? Are we going to have something unique from UVA? So that's one question I hope to ask, whether, this simulated data will be a good way to have a uniqueness for us. And what else? What are the things? Oh, where's Annie? So she mentioned, I think she mentioned, what we want to be known. The UVA has an opportunity for rural health. I think that may be a uniqueness for us, comparing with, other places. So that may be a good feature. Anything else I've missed on the other people?
Okay, so this is group 5, and we actually had a very similar question, at least the first part, to the last group. So I'm not going to go over everything we talked about because it overlaps, but I think there are some interesting common themes that maybe we should just mention. So our question, the first part was who should we collaborate with, right? So if we're going to have a precision health initiative, who should be the collaborative partners? And the one that I want to mention that has been talked about, I think, in every single group is the community, right? So we talked about the idea that if we can develop the best precision medicine or precision health instruments that we possibly could, but if they're not useful or if we don't have the community engagement, then they're worthless. So that was something that we spent a lot of time talking about. Maybe one other, this has been touched on a little bit too, but experts in in ELSI, the ethical, legal, and societal issues surrounding anything that we do in the precision health space. We talked about policymakers, right, being critical collaborative partners in any initiative that we would want to do. Something else that we talked about quite a bit about that's been touched on by others is education. Right, so we would really need to engage with educators at many different levels and collaborate with them to make any kind of precision health initiative successful. We talked about academic partners. Something that came up in the conversation about academic partners is something that Keith talked a lot about today, and that's just to make sure that diversity is included in kind of all the components that we think about in any such initiative. And so an example would be partnering with some of the HBCUs in the state and the surrounding area. Let's see, let me flip the page here. We talked about industry, in terms of technology being quite important. Then actually it was quite a bit of conversation around local collaborations, right? So we spent most of our time thinking about external collaborations, but it was duly noted that the internal collaborations would be really important. And, I think today has been, we've kind of seen that, right? Where there's so many areas of expertise that can kind of converge on precision health, and making sure that we're all talking to one another is really important. The second part of our question was the advantages that these collaborations would confer, and thinking about that strategically. So what could we do in terms of strategic collaborations that would give us an advantage? Admittedly, this was towards the end of the conversation, so we didn't talk about this as much. But again, community comes up, right? That being just such an integral part of any initiative that we would want to do. We also thought an advantage of UVA's location, right? So if you think about where we're located, we're pretty centrally located in a place where we could collaborate with lots of these different partners that we've talked about. And then we just hit on maximizing internal collaboration again. Did I miss anything that we should? Okay, thank you, and I guess we'll.
Okay, so this is group 7, and let me read our charge, because we try to keep on track. So what is the source of distinctiveness today at UVA that gives you confidence we can make a difference relative to our peers? Is this on? Is this on? You're here? Okay. And what gives you pause? And we really, Chris and I were just talking about that now, but we really didn't get to that in a general way. And then what would be a source of distinctiveness going forward if we fill the resource gaps? And we didn't get to that too much either. But let me try to, by the way, I think there were a lot of good comments, and I wrote lots and lots of notes, which we'll bring back to the group. And I tried to just, the takeaway message, all right? So first, we feel that there is a lot of excellence here in many groups and many areas, so that's a great basis for the distinctiveness, and integrating them is really important. And we feel like one of the distinctiveness is that medicine and health have integrated with engineering and data science. We have examples of this in progress already, including, for example, behavioral mental health and the Cancer Center, and I'm sure there are quite a few others. And as was just mentioned, there's also the notion of our location. And we saw some statistics where there's only like 5 universities that have an engineering school and a medical school within walking distance of each other. And this makes a big difference. So I think that builds the basis for a lot of uniqueness and distinctiveness. The fact that we built this data enclave that Don talked about, and it can be applied to different populations, and the broad populations we have access to is possibly another aspect of uniqueness. The fact that we have a lot of state support also can be another notion of uniqueness. And in going forward, there is a notion that, how do you do multi-scale, multi-level, integrated, interdependency processing of the data and so on, and if this can become a theme, that by bringing these groups together for this precision health for populations, that theme could end up being a very distinctive aspect of what we're producing. The Biocomplexity Institute, we think, is another kind of support for excellence, and that it does have kind of results and issues along those lines. Did I leave out any other key things that we talked about? No? Okay.
This was so fantastic, far exceeded my personal expectations, and I'm so grateful. And I know the whole steering committee feels the same way. So now you deserve a nice treat and a snack or two. So we've got our reception outside. Please feel free to mingle as long as you want. And we will also gather all the charts that you wrote on to make sure we've captured everything. So thank you so much.